Section 10.3. I'm calling this 10.3a because we're only going to focus in on geometric sequences, and we'll do 10.3b where we actually do the series, where we actually add up all those numbers on that geometric list, on the geometric sequence. Anyways, let's begin. And we will begin by taking notes and reviewing what we've learned so far in chapter 10. Remember, guys, the pause button is your friend, okay? So hit pause whenever you need to. Let's review. Let's begin with the word sequence. What does the word sequence actually mean? It means a list of numbers that has a pattern, okay? Now, we learned about two certain types of sequences. We learned about arithmetic sequences and geometric sequences, and they have these specific types of patterns. What is the difference between arithmetic sequence and a geometric sequence? Has a common difference, D, and a geometric sequence has a common ratio, R, okay? And when you're trying to find out whether you have a common difference or a common ratio, you have to use any number you want and the previous number before it, okay? So if you're looking for a common difference, pick a number, subtract the number before it, and see if it's in common between all the terms on your list. Geometric, that common ratio, you find it by picking any number and dividing by the previous number, okay? This is all review. You should be like, oh gosh, Salgado, I already know this. Please move on. And that's what I'm going to do. We're going to move on. Let's look at the book. And here we are on page 674. The title, Geometric Sequences and Series. We're going to focus in on sequences today. And let's move on, jump right into the key concept. What's the key concept in the book? It's this formula, okay? This is the a sub nth rule for a geometric sequence. And of course, this is very important. So let's go back to our notes and write this in. It's easier for me to write it in than you, huh? But before we actually jot this in here, let's go back and review the a sub nth rule that we already know for an arithmetic sequence. And the a sub nth rule for an arithmetic sequence is a sub n equals a sub 1, your first term on your list, plus parenthesis n, the number of numbers on your list. If you have 17 numbers, you're going to put a 17 right here, minus 1 times the common difference, d. How do you find the common difference? You take a number and subtract the one previous from it. Very important rule you have to have memorized. We did this last week. You should know it. Now let's move on to the geometric a sub nth rule. And the geometric a sub nth rule is the a sub nth rule we have here that we cut and paste straight from the book. Please jot this down in your notebook. This one also, make sure that you memorize both, and we'll get to practice on using and applying this a sub nth rule to find any number we want in a geometric sequence. But before we actually start applying it, again, a sub 1 means the same thing as a sub 1 over here. It's the first number on your list. Okay, now what does R mean? We already know that R is the common ratio, okay? Instead of common difference in arithmetic, we have a common ratio in geometric. And what does the n mean? The n is the same thing as the n over here. It's simply talking about the number of numbers on your list. So you might have a list that's 17 numbers long. That n would be 17 if there's 17 numbers on your list. And of course, this machine will be able to produce the list of geometric sequences that you might have, or that you have. So let's jump right into some examples and apply this a sub nth rule. We're looking at page 675, and we're looking at example 2. In this case, it says, write an equation for the nth term, the a sub nth rule. Write an equation, the machine that produces the geometric sequence. And here's your geometric sequence, okay? Instead of reading through the work that they have here, let's copy the original question and let's work it out in our notebooks, okay? So let's say, let's call this example 1. And the instructions in the book, they specifically tell you it's geometric, but they don't have to tell you that. What if I just said, here's a list of numbers and it goes on forever, ... and I ask you, what would be the 17th number, right? Well, you'd have to find the machine that produces this list. What do I mean by machine? The function machine. Like as in you plug in the number 1, and that'll give you the a sub 1 term. Plug in the number 2, it'll give you the a sub 2 term. Plug in the number 4, it should give you 32, right? So we want to come up with that machine. And in order to do that, we need to have the a sub nth rule memorized. So let's jot down the rule. A sub n equals, and let me tell you the thought process that I have. You see, on an arithmetic, you started with a sub 1 because that's the first number on your list. Right here, we're also going to start with a sub 1, the first number on our list. Now, before, on an arithmetic, what do you actually do on an arithmetic to get from one number to the next number? You either add a positive number or subtract a positive number, right? So there's a common difference in arithmetic. So that's why we would add and then parentheses n minus 1. But right here, we're not adding, right? What's happening from 2 to 8 or from 8 to 32? You're actually multiplying by a certain value to get to the next number. In other words, there's a common ratio right here. And you're not adding that common ratio. You're not subtracting that common ratio. You are multiplying that common ratio. So that's why the formula goes a sub 1 times r to the n minus 1 power, to the n minus 1 power, okay? So your a sub 1 term happens to be 0.5 in this case, or 1/2. You could write it as a fraction if you want. And your common ratio, let's do that one in black. The common ratio will be picking a number and dividing it by the previous number. Again, even though you could clearly see that you're multiplying by 4, to be on the safe side, always pick a number and divide it by the previous number. So if you go 32 divided by 8, what's 32 divided by 8? That is 4. Or if you happen to go, what's 8 divided by 2? 8 divided by 2 is also 4. Or if I say, what is 2 divided by 0.5, right? If I actually went 2 divided by 0.5, 2 divided by 1/2, that's really 2 times the reciprocal of 1/2, which is 2 over 1, which is also 4. So we could clearly see that the common ratio really is 4, okay? We could clearly see that this really is a geometric sequence as opposed to arithmetic. Again, what does that mean? Common ratio is 4. Well, that means that if you take the 0.5 and multiply it by 4. What is half times 4? It gives you the answer 2. What is 2 times 4? It gives you the answer 8. What is 8 times 4? It gives you the answer 32. So as you could see on geometric sequences, you really are multiplying by that common ratio that you found by taking a number and dividing it by the previous one. You're multiplying by that common ratio to get to the next number, multiplying by the common ratio to get to the next number. So the formula itself makes total sense. Why? Because what's the first number on your list? It's a sub 1, so that's how you start the formula. A sub 1 is the first thing on your formula. What happens from one number to the other number? Well, you have to multiply by the common ratio, so that's why we multiply by the common ratio. The only tricky part on memorizing is that you have to put the power of n minus 1. This is a power of this base, which happens to be the common ratio. All right, so what would the a sub nth rule be? Let's write it out. We have a sub n equals a sub 1, which is 0.5, or you could put 1/2 if you want, times the common ratio, which we said was 4, to the power of n minus 1, to the power of n minus 1. And you know what? The n, I'm going to put it in red so it could stand out to you. Why? Because we're done. This is the machine. Now, in reality, guys, finding the geometric a sub nth rule is easier than finding the arithmetic a sub nth rule. Why is that? Because on the arithmetic, you would plug in a sub 1 at the beginning. You would put plus the parentheses n minus 1 times a common difference d. You would have to do some math afterwards. You would have to distribute the common difference d. Let me actually go back up here to my notes so you know what I'm talking about. See, on an arithmetic, what we did last week, it's actually more challenging than this week. Why? Because you would plug in your a sub 1, you would plug in your common difference, you'd have to distribute and then combine like terms. You had to do some math to get the a sub nth rule. Right here, when we do the geometric a sub nth rule, you just plug in a sub 1 and you plug in your common ratio and you're done. There's no math to do. So you guys should be happy about this. All you do is identify your a sub 1, identify your common ratio, plug in a sub 1, plug in your common ratio, you're done. That's a machine. Voila. Ta-da. Anyway, let's take this a step further. Why do I want to find this a sub nth rule? Because this is the machine that produces this list. If you're not too sure if you did this right, what could you always do? You could plug in the number 1, and it should give you this first answer 1/2, right? If you plug in a 1 right here, what's 1 take away 1? It's 0. What's anything to the power of 0? It's 1. And 1/2 times 1 really is 1/2, or 0.5. If you happen to plug in, let's say 3 right here, you should get the third number, a sub 3, which is 8. Plug in 3 right there, you get 3 minus 1, that's 2. What's 4 squared? That's 16. What's 1/2 times 16? That's 8. So it really does give you that a sub 3 number when we plug in 3. So that's why this a sub nth rule is so important, and that's why it's so important to memorize, just like we did last week when we memorized the arithmetic rule, a sub nth rule, we need to memorize the geometric a sub nth rule. Okay, again, a sub n equals the first number on your list times the common ratio to the power of n minus 1. Okay, it's actually easier than this one, because over here you plug in a sub 1, you plug in your common difference d, you have to distribute and then combine like terms. Right here, plug in a sub 1, plug in your common ratio, you're done. Nothing to do. You already have your rule. Amazing, right? Okay, so if we look at our a sub nth rule and compare it to the book, we see that it's exactly the same. A sub n equals, I use the fraction 1/2 times that common ratio 4 to the power of n minus 1. Cool. And of course, not all questions are going to be that straight up, that easy. What do I mean by that? Here's another example where they don't give you a sub 1, they give you a sub 4, and they tell you that a sub 4 is 5, and they give you the common ratio 6. And they want you to find the a sub nth rule given this information. So let's do that. Let's cut this out right here, and let's move it to our notes and write it as example 2 right here. So just like any other math problem, we take what they give us to find out what we don't know, or find out what we need. So what do they give us? They tell us a sub 4 equals 5. So we know that a sub 4 is going to go right here where it says a sub n, which technically means that we know what the value of n is. You see, n is really 4. Okay, so we could actually jot that down on the side right here. We know n is 4. That's information that's given to us. Okay, we also know that a sub n is 5. They give that to us, right? A sub n equals 5 right there. And they also tell us that our common ratio is 6. Okay, common ratio is 6. So let's take the common ratio 6, put it right here where the r is at. We don't have a sub 1, so we're just going to write it as a sub 1. But we do know a sub n, which we're going to replace a sub n with 5. And we also know that n equals 4, which means that this n up here is going to be 4. And again, let me repeat. In any math question, when they tell you to solve for a certain variable, take what you have, plug it in to find out what you don't know. Okay? So let's plug in our a sub n. Right here, this a sub n, we're going to rewrite it as 5. So we have a 5 equals the a sub 1 value. We don't know, so I'm going to leave it, a sub 1. My common ratio, do I know my common ratio? Yes, I do. My common ratio is 6. So I'm going to put times 6. And it's going to be to the power of n minus 1. To the power of n, we said n was 4 minus 1. And this is all in the exponent position. So we need to simplify this and then solve for a sub 1 to get the information that we need, right? What is the information that we need to write the a sub nth rule? We need the a sub 1 and the r. We already know r, but they didn't give us a sub n, they gave us a sub 4. That's why we're plugging in all the information that they gave us to be able to find what we need. We need that a sub 1. So what is 4 take away 1? That is 3. So what we have so far is 5 equals a sub 1 times 6 to the power of 3. And then 6 to the power of 3 is, that is 216. So let me rewrite what we have so far. 5 equals a sub 1 times 216. And then we are going to get the a sub 1 by itself. So you don't want that multiplication of 216. So we're going to divide by 216. It's going to cancel divide by 216. And there's our a sub 1 value. A sub 1 equals 5 divided by 216. Now that we have our a sub 1 value, which goes here, which is going to be 5 over 216, times the common ratio, which they gave us was 6, we'll have our actual function machine. That's what we wanted. We wanted the a sub nth rule. The a sub nth rule for this example number 2 is a sub n equals a sub 1, 5 over 216 times the common ratio, 6. If you want, you could put it in parentheses. And then to the power of n minus 1, n minus 1. Ladies and gentlemen, this is the a sub nth rule that produces the list, if you had a list. Okay, so if you're confused and you're like, I'm not sure if I did this right, what could you do? Well, they give you the 4th number on the list. You could go ahead and plug in the number 4 and see if it actually gives you the answer 5. So when you plug in a 4 up here, that'll be 4 minus 1, which is 3. 6 to the 3rd power, you do exponents before multiplying. 6 to the 3rd power is 216. So you really have this fraction, 5 over 216 times 216. The 216s cancel out. Your answer is 5. And that makes total sense because when you plug in a 4, we got out of 5. So you could be comfortable about your a sub nth rule that you came up with. And there's the work shown in the book. It's the same exact a sub nth rule that we got, 5 over 216 times 6 to the power of n minus 1. Okay. So your practice for today, your assignment for today is due page 677. This is page 677. And you're going to be doing numbers 2 through 7. I'll do half of them. You're going to do the other half. You're going to be doing about 3 questions. All right. So let's jump right into this. I'll do let's do this one, number 4. That one's interesting. Okay. So they're telling us that it's a geometric sequence. They want us to write the a sub nth rule. So let's begin with this problem on number 4. So we know that the a sub 1 term is this guy right here, the negative 4. You know, let's write it over here. A sub 1 equals negative 4. We might as well write down the a sub nth rule of this geometric series. The a sub nth rule of this geometric series is a sub 1 times the common ratio, r, to the power of n minus 1. n minus 1. Okay. So we have the a sub 1 being negative 4. So let's plug that in. The common ratio, we need to figure what that is by taking a number and subtracting, or not subtracting, dividing by the previous number. So if you go negative 64 divided by positive 16 on a calculator, it'll give you negative 4. Or if you do positive 16 divided by negative 4, that'll also give you a negative 4. So the common ratio, and a lot of times books don't write it in parentheses. I like to write it in parentheses because if you don't put it in parentheses, that common ratio of negative 4, okay, again, we said the common ratio is negative 4, so we have a sub 1, we have common ratio being negative 4, and if you don't put it in parentheses, you might make the mistake of thinking that this says negative 4 take away 4, which is incorrect. So we have the a sub nth rule being negative 4 times the parentheses negative 4 to the power of n minus 1. Now let's say you weren't too comfortable about your a sub nth rule here, and you're questioning, maybe I made a mistake. I don't know, did I get this right? You could plug in the number 1, and that should give you your a sub 1 term, which is negative 4. You could plug in the number 2, and that should give you your a sub 2 term, which is 16. You could plug in a 3, and it should give you negative 64. So it's up to you. Let's double check. Let's plug in a 1 right here. 1 take away 1 is 0. Anything to the power of 0 is 1. Negative 4 times 1 is the first number, negative 4. So that's how you could feel more confident about your answer. So going back to the book here, we just did number 4. I'm pretty sure that you guys could do numbers 2 and 3. It's exactly like the way we did number 4. Let's take a look at I want to go for the hardest one, number 6, right? On number 6, they give us the a sub 6 term, the 6th number on our geometric sequence. And also they give us a common ratio, which happens to be a fraction. A lot of people freak out with fractions, so let's do that one. So here we go. They give us some information. They give us a 6th term. They give us a common ratio. They don't give us a list. But what's the formula? The formula is a sub n equals, it always starts with a sub 1. It doesn't matter if it's arithmetic or geometric. So you always start with a sub 1. Geometric, remember, you're multiplying by a certain value by that common ratio between the terms. So you're going to be multiplying right here times that common ratio. And it's to the power of n minus 1. Okay, so here's your geometric rule, the machine that'll produce your geometric list or sequence. And we need certain items to be able to write the rule. You need the a sub 1. They don't give you a sub 1. They give you a sub 6. We need an r. They give you the r. Okay, so let's plug in what they give us, and that way we could find out what we need. Okay, so we know we need an a sub 1 and we need an r. So a sub 1, we don't know. The r, we already know, is 3/4. Okay, so these are the two things that we need. Let's just plug in what they give us. The a sub 6 instead of a sub n, let's plug that in. A sub 6 equals a sub 1, we don't know, times r. What is r? r is 3/4. They give that to us, to the n minus 1 power. Okay. Now, we know that a sub 6 equals 1/8. So why didn't I just put a 1/8 right here? Well, I will put a 1/8 right here because a sub 6 really is 1/8. But the reason why I put the a sub 6 in place of a sub n is so that it'll be crystal clear that I replaced this n with this number 6, okay? Which in turn is gonna replace this n up here, actually this n down here, with that 6. So we could even write this down on the side so it'll be more clear. N equals 6. And we get that from this little 6 at the bottom, because we know that this is really a sub n, where 6 is n, so n equals 6. So we take the n, we put a 6 right there. We take the n, let's put a 6 right there as well. So I'm just gonna overwrite it. There's a big giant 6 right there. So it really says 6 take away 1 as the exponent up there. And now, let's actually replace a sub 6 with the 1/8 that a sub 6 really equals. So I'm gonna take the 1/8 and put it right here in place of the a sub 6. So I have 1/8 equals a sub 1 times that 3/4, the common ratio, to the power of 6 minus 1 is really 5, okay? So what we get here when I do the 5th power of 3 to the 4th is 243 over 1024. Okay, and we still have the times a sub 1 equals 1/8. Okay, so let's get the a sub 1 by itself. So I need to get rid of this fraction. I'm going to multiply both sides by 1024, which will cause it to cancel. What I do to one side, I do to the other, 1024. So that really becomes a 1024 divided by 8. And the answer to that is 128. And of course, I'm using a calculator. So what I end up with is 128 equaling a sub 1 times 243. So I still need to get rid of the multiplication of 243. And I do that by dividing by 243. Dividing by 243. So I just tried to reduce this with the calculator and it seems to not be working. So I'm assuming that that's my answer. A sub 1 equals 128 over 243. So what was the whole purpose of doing all this work? Well, they wanted us to write the a sub nth rule. And in order for us to write the a sub nth rule, you need a sub 1 and you need that common ratio. They gave us a common ratio, 3/4. We just found out that the a sub 1 was the fraction, that nasty fraction, 128 over 243. So now that we know the a sub 1 and we know the common ratio, 3/4, we should be able to plug it all into the a sub nth rule. So let's write that down. A sub n equals a sub 1, which is 128 over 243, times the common ratio, which we said was 3/4, to the power of n minus 1. Now that looks like an ugly function. I mean, this is ugly. So I'm not too sure about this whole thing. How could I verify? I could actually verify by plugging in the number what? The number 6, and seeing if the whole thing equals 1/8. So just for funsies here, let's actually calculate a sub 6, which would mean I'm plugging in the number 6 into the function. So let me first get some space and let me show you. Plugging in the number 6, it would look like this. And of course 6 minus 1 is 5. And when we do 3/4 to the 5th, 3 to the 5th is 243, and 4 to the 5th power is 1024. And of course, we need to multiply that by this 128 over 243. As you could see, the 243 up on top will cancel with the 243 on the bottom. and you end up with 128 over 1024. Questions, could you reduce that? The answer is yes, you could reduce by 128. All right, if you reduce 128 by 128, that becomes 1. If you reduce 1024 by 128, it becomes 8. So a sub 6 really equals 1/8. So this whole work right here is unnecessary. This whole work was just for us to check and see if we got the right a sub nth rule. Does a sub 6, when I plug in 6, do I get the answer 1/8? This is saying that our 6th number on the list is 1/8. And if we actually had our list, we could go back to the 6th number. But right here, we don't have a list, but it does say a sub 6, the 6th number on the list, is 1/8. So again, this work right here was just to verify. You don't have to do it. I'm just saying, if you're ever doing a quiz or test and you want to make sure that you actually came up with the right a sub nth rule, you could plug in whatever number they gave you and see if it actually does give you a 1/8. Remember, these are your inputs, the answers are your outputs. So this is saying that the 6th number on the list is 1/8, which means that if this is correct, when you plug in a 6, it should give you the answer 1/8. And as you could see, it did. We plugged in a 6, we did the work, it gave us the answer 1/8. All right, guys, you guys have the rest of these to do. I did 2 of the harder ones. I'm pretty sure you guys could do the rest. And the answers are right here. As you can see, we got that exact a sub nth rule for number 6, 128 over 243. We actually verified that this is correct by plugging in the number 6 right in here, doing all that work, and it gave us the answer 1/8. So here are your answers. And as always, if you guys need help, send me a text. All right? Hope you guys are doing well, and see you on tomorrow's video.